Welcome back to Aurora Tech Channel. Today, I will be reviewing the Laser Pecker LP5. Last year, I reviewed the LP4, which had a 10-watt diode laser plus a 2-watt fiber laser. The LP5 has upgraded both modules to 20 watt, so we can expect it to work on more materials at a higher speed and with stronger cutting power. Unlike traditional laser engravers that use stepper motors to move the whole printhead around, this LP5 uses a set of mirrors inside the toolhead to reflect the laser. There will be no movement when engraving, so it can engrave at a much faster speed compared to regular laser engravers. The claimed top speed is 10,000 millimeters per second, which is 600,000 millimeters per minute. The dot size of the diode laser is 0.08 by 0.1 millimeter, and the fiber laser dot is much smaller at 0.06 by 0.06 millimeters. The working area of this machine is 160 by 120, but if you add the extension module, it can expand to 160 by 300 millimeters. It comes with its own software that can switch between diode and fiber lasers, so you can use both lasers in one single job with different operations. There are also many optional accessories like the slider, rotary roller, smoke purifier, and safety enclosure with the camera. I would like to thank Laser Pecker for sending us this machine to review and for sponsoring today's video, and with that, let's get started. Besides the LP5 machine, Laser Pecker also sent us a smoke purifier. All parts are protected and separated by laser cut foam. As this is the deluxe bundle, it comes with other accessories as well. For a standard machine, you will get the laser head, a protective cover with an exhaust fan, ducting, a base plate, a power supply, the Z-axis module, a cutting bed, a toolbox, some cables, and user manuals. If you ordered the deluxe bundle, you will also get the rotary roller and a slider that allows you to work on materials as long as 300 millimeters. To put the machine together, you need to connect the Z-axis to the base plate, put the laser head on the Z-axis, put the cutting panel on the base plate for cutting, and attach the protective cover with the exhaust fan. Connect the cables for the Z-axis and exhaust fan. In order to operate the machine, you also need the USB key. Connect the USB cable to your computer and connect the power supply. Now the machine is ready to use. You can connect it to the smoke purifier if you don't have any existing ducting, or you can just connect your own ducting to exhaust the smoke outside. To set the focal length, simply use the up and down buttons on the Z-axis to align the two dots with each other. You can long press the buttons to quickly reach the rough position, and short press to fine-tune the exact focal length. The machine comes with its own software. You can download the latest version from their website. After the software is installed, we will connect the machine with a USB cable. Once you select the COM port, you will see the connection icon turn green. As the machine also supports Wi-Fi, you can also select your SSID and enter your password. For some reason, the PC software can't find the machine over the Wi-Fi, but it works when I enter the machine's IP address directly. However, when I use the mobile app, it can find the machine without any issues. Let's start with a simple SVG pattern engraving. I would just pick a random one from their library. I also want to cut it out after the pattern is engraved, so I will select offset and enter 2 millimeters to draw a line outside of the shape. For the parameters, I will use 100% power and 40% depth. When converting to speed per second, it'll be around 718 millimeters per second. For the outline cutting, I will use 100% power and 95% depth, which is about 6.26 millimeters per second or 375 millimeters per minute. Let's do a preview and position the material. Then, it will show another screen to confirm the parameters for these two operations. If the numbers are correct, we can send the job to the machine. For plywood engraving, we will use the diode laser. It seems it's moving pretty fast. The engraving job took 1 minute and 8 seconds to finish. Next, we will cut it out. overall quality is pretty good. But as this type of laser doesn't support air assist, the cut may not look as clean as our traditional machine. The laser is also coming from the center, so you can see the plywood is cut at an angle. Next, I will engrave a photo. As you can see, when using photo mode, I can't see the icon to show the speed in millimeters per second, so I will just try 100% power and 10% depth. Use the preview frame to align to the material, and then we can start the job. The job took 6 minutes and 20 seconds to finish. I think the result is a bit too light, so I will try again, but increase the depth to 20%. This time it took 8 minutes and 46 seconds. 20% depth looks a bit too dark, so I'm guessing somewhere between 10 to 20% would be perfect for photo engraving on plywood. Let's try the fiber laser. I will engrave a 52mm diameter logo on this coated aluminum card. With 100% power and 10% depth, it took less than 8 seconds. It seems the coating didn't burn off completely. I will slow it down a bit to 20% depth and make another one. This time, it takes 3 seconds more and finishes in 11 seconds. It looks much better, but I think slowing it down to 30% could be even better. It took 16 seconds to finish. Let's compare all of them. Using 100% power and 30% depth gets the best result on this coated aluminum card. It takes a bit longer, but 16 seconds is still very fast. I will use the same power and depth setting on a Slate coaster. The size of the logo is 95mm, and it took about 46 seconds to finish. The result looks very nice, as the marks on the slate are clear. I will try another one and engrave at 60% depth to see what kind of result we can get. This time it took 4 minutes. When you compare them side by side, the 60% one does burn some depth on the surface. It's hard to see on camera, but I can feel it when touching the surface. Next, I will try to work on acrylic. I will use the fiber laser at 50% power and 50% depth to engrave a sample SVG file. The engraving job took 1 minute and 30 seconds. Then, I will use the diode laser to cut it out. Since you can't use too much power while cutting acrylic, I will just use 50% power and 95% depth to run 3 passes. It took 4 minutes and 20 seconds to finish. The engraving result is really nice, and the cut is also fairly clean, except I had to snap off the left side. As I only use 50% power to prevent the acrylic from melting, I think adding another pass would be perfect. It's still cut at an angle, as the laser source is at the center. Then, I will try to make a logo on some ABS camera lens caps. First, I will try using the fiber laser. For a small logo like this, it'll only take 3 seconds. It can engrave some depth, but the mark turns a little yellow. I will make another one with the same parameters using a diode laser. For the diode laser, it didn't change the color of the black ABS. When putting them on the lens, I think both look alright. I won't say which one is better, as this is honestly just up to personal preferences. Up next, I will try some leather. After some trial and error, I found that using 50% power and 60% depth for engraving, or 50% power and 90% depth for cutting with 3 passes can get a better result. The last pass isn't cutting anything at all, as 2 passes can cut through completely. Running the final pass is just to make sure the edge is cleaner. These are the unsuccessful ones I tried previously. I will use the same parameters with a diode laser to cut another one. For engraving, the fiber laser looks a little better, but for cutting, I think the diode laser looks cleaner. As fiber lasers can engrave on metal, which is challenging for diode lasers, I will try to engrave some text on a standard 20 by 20 aluminum extrusion. The result is okay, so let's try some raw aluminum with the same parameters. It is also successful. I think it'd be cool if I make something with extrusions or make an aluminum CNC part with my name on it. Up next, I will try to engrave on steel. The sparking when engraving on the necklace tag looks really cool. Using the laser preview frame, it's pretty easy to align on small objects like this. Next, I will try to engrave on brass. First, I will try 50% power and 81% depth. It took just 42 seconds and left a light mark on the brass coin. I will run another pass with 100% power and 90% depth and see if we can get a different result. You can see some brass dust is burning off this time. It takes about 2 minutes to finish. I prefer to spend a little more time to make some depth on the surface instead of just marks. I previously engraved a logo with the same 50% power and 81% depth. I think it's too light, so I will use 100% power and an even slower speed at 95% depth to reuse the same coin and make another logo. This time, it took a little less than 20 minutes. It burns off a lot of brass dust. I will try to clean it up and see the result. There was some depth engraved on the surface, and the color also changed completely. I'm not sure why the top part looks a little different, but the rest of the surface looks alright and the alignment is also accurate. Next, I will engrave a 3D bitmap on another brass coin. The software can create multiple layers based on the shades of the bitmap, allowing for a maximum of 254 layers. The manufacturer also suggests using a fan to blow on the workpiece to ensure that fine dust doesn't stay on the surface after each layer is engraved. I will connect an array of 24-volt fans to blow directly at the coin. After about 3.5 hours, the engraving was finally finished. It took quite a while, but the result is cool. Next, I'll do some metal cutting. The machine claims it can cut up to a 1mm stainless steel sheet using 100% power, 85% depth, and 15 passes. Although I don't have a 1mm steel sheet, I'll use a 0.5mm sheet with the same parameters to see how many passes it takes to cut through completely. The heart shape dropped off just before the 7th pass was finished. While the cut isn't exactly clean, it does manage to cut through the steel sheet. As the deluxe bundle also came with a slicer for you to work with larger materials, I will put a letter-sized piece of plywood on it. However, since the cheap plywood I bought from Amazon isn't completely flat, I have to use some binder clips to secure it on the bed. I will engrave another photo with 100% power and 10% depth on this plywood. It took 41 minutes to finish. I think it looks even lighter than the smaller photo I made earlier. Sometimes, plywood is not very consistent. I will run another pass at 100% power and 15% depth. It took 6 minutes more, but the result is much better this time. Finally, I will test the Rotary roller. It's a claw-style roller, but it does not look that different from other traditional rollers. It came with 3 sets of holders for you to hold large objects like mugs, as well as small objects like rings. I would just engrave some patterns on a red oak cylinder. Since there are no parameters for red oak in the software, I will use the parameters for walnut. It seems 50% power and 89% depth is still too light, so I will run another pass with 100% power and 60% depth. Okay, this time the pattern is darker and the result looks better. Let's talk about the pros and cons of this machine, starting with the pros. 1. The 20-watt fiber laser is powerful. With a 20-watt diode laser, it can engrave on almost anything. I tried wood, leather, acrylic, ABS, slate, steel, brass, and even raw aluminum, and all of them got pretty good results. I can even cut some thin metal sheets with a fiber laser. 2. It's fast. The 20-watt fiber laser can leave marks on different surfaces at a very high speed, and some smaller jobs only take a few seconds to finish. Even when using the 20-watt diode laser to engrave on wood, it finishes much faster than a traditional machine, as using the mirror to reflect the laser is faster, and it saves a lot of time on travel. 3. 3D engraving is very interesting. It works like 3D printing layering. It can turn your grayscale bitmap to as many as 254 layers and make 3D effects. 4. This machine has a high-quality build, and its appearance is nice. The small details of the machine are well polished, and it's also compact and doesn't require a lot of table space. 5. It has a full range of accessories. I found the slider to be pretty useful. It can extend the whole working area to 300 by 160 millimeters, and I can engrave a large photo at 299 by 159 millimeters that almost uses up the entire working area. Another interesting accessory is this safety enclosure, but somehow it was not in stock when we tested the machine. Inside the enclosure, there's a camera that allows for easier alignment and batch production. This seems pretty smart, as they claim to be able to position the job on all materials automatically. Now for the cons. 1. It would be better to use speed instead of depth. Using depth and percentage means you have to do a lot of guessing, especially if you have experience using other engravers. It'll take some time to adapt to using the percentage of depth to control the actual speed. There is a conversion button, but for image mode it won't show. 2. The machine can do rectangle previews, center point previews, as well as pre-scan the G-code if you change your job to line mode. This will allow you to position the material more accurately. However, when your job is more complicated than a simple SVG, it'll be pretty confusing, and the preview won't work too well in this case. It would be better to just preview to outline and skip all the details inside. As for alignment purposes, the only thing that matters is the outline. Moreover, it also can't preview text and just shows it as a rectangle. 3. The machine cannot be found by the PC software over Wi-Fi, but entering the IP address works normally. The mobile app can find the machine over Wi-Fi without issues. 4. This kind of laser machine may not be ideal for cutting. First, it can't be equipped with air assist, so the cut may not be as clean as a normal diode machine for wood cutting. As the laser module is fixed, it has to use mirrors to reflect the laser to reach the engraving areas, so when cutting a larger object away from the center, it will cut at an angle, but that's how this type of machine works. In conclusion, I'm happy with the 20-watt dual fiber and diode laser. They allow you to work on a much broader range of materials. The whole machine is a high-quality build, and the small details are also well polished. Most minor issues are related to the software, but Pecker has kept updating their software regularly, and I hope to see more improvements to address the issues I mentioned in the cons section. If you are interested in this LP5 dual laser machine, I put the link under the description. I also included a link to my website, auroratechchannel.com, which monitors the prices of over 150 popular 3D printers, laser engravers, and CNC machines. That's it for this video. If you like this video, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.